Hello, everybody. It is November 12th, and this is the OLM Dev Working Group. Our agenda today includes continuing the discussion about scoping operators in OLM, and an additional item where we are going to speak or review an RFE for decoupling APIs and controllers. And with that, I'm going to hand it off to Chris Johnson, where we'll kick off the scoping discussion.
Awesome. Thanks. So we've already had a couple of discussions over the past several meetings talking about the fundamental problem of how do you scope an operator to a cluster or namespace, basically the tenancy problem having to do with API management, and then how do you decouple it from the controller and all that kind of stuff. And so I brought a whole army of people from me who have various opinions and various use cases in their heads on how we've been getting feedback from customers and how they've been, I guess, trained on how Kubernetes and how they've been installing it and how they're using it and how they're expecting to use operators and workloads on their clusters. So James, who's here, has been thinking about this. I've kind of tagged him because he's kind of in the thick of it. He's got some ideas. And so James, if I could put you on the hot seat, if you could talk about from the Cloud Pak for Integration perspective on what you guys are seeing. And maybe we can kind of clarify our use cases to you, because Evan kind of came back to us with your use cases and what you pursue those. And then James kind of took them apart and kind of came up with his kind of view of that.
Yeah, Chris, I also have a perspective, James, if that will help too. So
cool, absolutely, Mike. But seeing as Chris called me out, I didn't kind of pull Evan's stuff apart. I think Evan's got a really good set of those 6 kind of top level kind of use cases that we want for cluster administrators and for developers. I would kind of add to that one of the things that we have been aiming at being able to do is allowing namespace admins as well as cluster admins to install operators. Whether that changes this conversation much at all, I don't know. I did take a look at Evan's presentation as well from a perspective of if we were to decouple APIs and controllers, as we've discussed in the past, how would that affect those use cases, and would that help relieve some of the pain from those and enable us to do more without needing to go as far as splitting up into multiple clusters or using I don't know what the right term for it is. The multi-tenancy aspect, where you have a set of masters that run multiple clusters. Is there a term for that we use? At the moment, I've just seen it in presentations as multi-tenancy, but that seems vague. But I feel like maybe we need to come up with something for that. But the question I would ask at the top of this is, what decision points are coming up? I know that in IBM, we're thinking about the customers that we have and the way that they're deploying at the moment, and making sure that we don't lose that functionality. But from last week's call, I feel like there might be a move towards the multiple clusters in one set of masters type model to fix some of the underlying issues. But is that a decision that we need to be making, or is that would that be an exclusive decision that would mean that work on OLM would stop? Those are the kind of questions that I think we're most interested in. Go on, Mike. What's your perspective?
Yeah, well, I have a very, I guess, pragmatic view. I'm not after all 6 of the use cases. I'm responding directly to what some of our largest customers are telling us. If you'd like, I could show, a couple slides or a few slides on that and kind of maybe use that as a forum to get feedback as well. Like to do that?
So what are we aiming to get out of this discussion?
So from my standpoint, I guess I'm looking for guidance really on where should we apply our efforts, right? So I want to clarify I want to make sure Daniel and the OLM team, you guys understand our perspective on the problems we're trying to solve. And we have to solve them regardless. And so we need to figure out, where do we put our efforts? Do we start enhancing OLM to be able to handle these scenarios? Do we do something one-off, something on top of OLM, or do we focus our efforts in Kubernetes to try to get them to reduce those sharp edges? We're just trying to figure out collectively, how the heck can we apply all of this energy to satisfy these customer scenarios. So does it make sense if we kind of if we might clarify the customer scenarios for you, Daniel?
Yeah, I think that makes sense, because I think there are some assumptions there that are not necessarily tied to what we are talking about here, which can be solved in a different way. So I want to make sure that we're really getting to the core of, why do you really need to install an operator more than once on a single cluster? What is the driving factor behind that?
Yep.
Okay, so let me just give you some feedback from the standpoint of talking with customers. We've been focusing on operator design around minimizing cluster permissions. And the reason is that a lot of our customers, and I'm not going to call it tenancy, I'm going to call it workload isolation. They use OpenShift projects or namespaces for workload isolation. They expect they can install products in more than one space, one or more spaces. They expect that these things that they install will not unexpectedly create new namespaces. I mean, that's something that they're surprised by for us, because they really maniacally manage those namespaces. They expect we carry no permissions that can affect other workloads and namespaces. And they scrutinize and expect explanation of any cluster permissions or non-restricted SCCs that we run with. Customers I've talked to also have an aversion to installing operators in all namespaces mode, because it escalates their permissions, and it's seen in all namespaces as installed in the operator hub. And so for some of our large customers that have what I would call sizable clusters, they kind of divide roles up this way. They have a cluster admin who determines which operators are going to be installed in the cluster, figuring out which namespaces or projects are going to go into when they're installed, and establishing user access for their various lines of business or development teams to those projects or namespaces. Whereas there's a namespace or project admin or user that they can log in to the namespace or namespaces they have access to, and see the operators they can access, which means creating CRs and deploying workloads, developing applications that use the deployed workloads and use those deployed workloads. And the expectation then on this page is that, okay, I have a number of teams that I'm sharing this cluster with. I expect from a security perspective some level of workload isolation. Not all 6 of the stories, but some level of that. And that's really what we're dealing with. So we have cloud packs that are installed in namespaces and some common services that interact with these namespaces. And customers don't mind that, but they don't want us to carry permissions that would allow us to have, from a security perspective, the ability to interact or even perform operations on other projects that they have going on that have nothing to do with our offerings, okay? So this kind of interaction of workloads across namespaces within our cloud packs and common services is fine. This kind of interaction is really not, okay? So if we're carrying cluster permissions or not running in restricted SCCs, this is their concern, that we have the ability to affect, from a security perspective, other workloads that they want to have isolated, okay? So we've been working on how our operators and operands from one namespace can kind of project permissions just using roles and role bindings into other namespaces. Do that in a controlled way. We'll do it automatically, but if customers want to manage it, they can manage it. This is kind of a subcluster-like scenario, but we are managing this. We do have to use a few cluster permissions to do this, but we also, if the customer is uncomfortable with that, we'll give them administrative commands that do things like project common services, watch and CRUD operations into other namespaces specifically, so they can completely manage it. that's the direction that we're going. That's the gist of what we get from our customers. You know, we have a way of doing that. If our operators and our operands are running in this common services namespace, and we have CRs and can operate on resources, we have an operator that will actually list the namespaces in the scope, project the role bindings into those namespaces, maintain a list of namespaces that the operators can watch, and using this combination, we actually can then project into specific namespaces. And once we've done that projection, we don't need any cluster permissions to watch just that group. Very similar to the operator group notion, although we do it for operands, not just operators. Sometimes the operands that are deployed need those kinds of permissions as well. Some of them are controllers and so on. You know, we need cluster permissions to do this, or we can provide the customer with this as an administrative command in that particular namespace that allows that projection to occur. So that's the set of scenarios that we're working very hard on realizing, but they're all around this set of customer expectations that we're seeing. So let me just pause if there's questions or discussion on that. It's really the use of workload, or the use of projects and namespaces for workload isolation. I'm not going to call it tenancy. We're not trying to put different versions of operators in different namespaces, but we are putting operators in namespaces, and I believe this is what customers are currently doing with OpenShift. From my experience and the feedback I get, using those projects and namespaces to isolate from a security perspective. Certainly not from a resource utilization perspective, but a security perspective, doing this workload isolation, and then making sure that nobody's quote running as root or is as close to running as root, where they have permissions across the whole cluster that they don't know about, that they don't have explained to them, that they don't know what they're going to do.
And Mike, I wonder if the concern would be the same if we were not talking about products here, but about Kubernetes built-in controllers. So is it a security concern for a tenant of your cluster that their pods are reconciled by the same Kubernetes controller as other pods and other tenants they don't have access to?
Well, I think if it's seen as a Kubernetes service, an OpenShift service, legitimate service to actually be looking at various projects and reconciling CRs in those projects for that service, that's fine. If it's a set of services that are oriented around a particular set of offerings like ours, like these common services here, they're not really supplying, OpenShift-like services. Now, there are services we're moving into OpenShift, and we're happy to do that. But there's a set of services here that these cloud packs that are implemented as operators and respond to CRs in these namespaces that they don't really want them to have the authority, particularly CRUD authority. Read is probably okay in these other namespaces. So I don't know if they would think about it as which controller is reconciling which thing. But to your question, yes, they don't want our controllers and common services reconciling anything in these other namespaces. But they see it as a permission thing as opposed to which controller is reconciling what. Okay. Does that make sense, Daniel?
Yeah, I guess I get the analogy. I guess I'm wondering what the difference is, right? So if they are concerned about a security issue in one of your controllers, then they should also be concerned about security issues in core Kubernetes controllers, right? So aside from the fact that, we could very likely just hide the availability of those operators from those other tenants, the brown squares on your screen.
Mm-hmm.
And do not project CSVs in there, and do not create RBAC to use the CSVs, CRDs in those namespaces. But in theory, if a cluster admin would put a CR there, it would likely be reconciled by that operator. It's just that the tenants would never see the operator. The tenants wouldn't be able to instantiate an operator service. So is that enough of security, or does it really need to be a hard tenancy where your common services controllers don't have RBAC, and by the means of Kubernetes, RBAC can never even access that namespace of workload 1, 2, and 3 in this picture?
Well,
I think there is a
essentially
difference when you're talking about an operator controller versus a Kubernetes controller. I mean, a Kubernetes controller is kind of a Kubernetes native controller. It's there to do the job of creating deployments and pods and things that are really Kubernetes native concepts. When you've got an operator controller, what that's normally doing is creating Kubernetes native objects, right? Which is it's a bit different, and it's a bit more in that there's more scope there for stuff going wrong, I think.
But you see, the fundamental issue is that because you cannot restrict core Kubernetes controllers, you also cannot restrict, well, you can, but then we have a bunch of other problems, right? So we are doing what you're doing, or what you're intending to do today, right? If you scope an operator with an operator group, it'll only get RBAC and watch configuration in the namespaces that the operator group points to. That raises a number of issues in the UX around dependencies. So what it comes down to, and this is what Evan alluded to in the last presentation, is there's no sane way dependencies will work in this manner with a simple to understand UX. So we can either have no dependencies, or we don't have scopes. And I think what we come down to, there's no sane way to have both.
I mean, I think I would disagree with saying that there is no sane way to do that with UX. I mean, I see it's a UX problem, and I see it's a tricky one, but I think there are ways that customers could understand how that works.
Then I'd be super interested to hear those, because we've been
I think we need
this problem for a very long time, and talked to API people for a very long time too, and they all told us the same thing. So super interested to hear what you have to present there.
So separating the APIs, I think, will help with some of that, separating APIs and controllers, and dealing with kind of management of APIs that exist in the cluster. But I think that one of the biggest concepts that makes it difficult for customers to understand compared to other systems is the inability to override a global scoped operator, a cluster scoped operator. I think if we could work out a way to allow you to have an operator installed at the cluster scope, and then install another operator at the project scope that supersedes that one within that project, that could solve a lot of the problems and feel a lot more like a traditional system of how things are installed. How to do that in a Kubernetes way, maybe that's not possible with convention in terms of putting code into the operators so that the cluster scoped operator would ignore projects with annotations or something. That there must be a way that we can come up with to make that work. And if we can make that work, I think the UX problems become a lot simpler. Because we can say, in this namespace, this API is managed by this controller, and in this namespace it's managed by this controller, and that kind of thing.
Yeah, the other difference here, James, that I see is that your regular Kubernetes or OpenShift controllers in the UX don't show up as being installed in your namespace. Yet if we install our operators in all namespaces mode, customers get concerned because they see that operator running all of their namespaces, quote, running in all their namespaces, watching all their namespaces. So the UX is putting in front of their face that now you have these additional global operators that maybe have come from another vendor, and they have a level of trust of a vendor that they want to isolate that kind of scope and workload. And that's why they generally like to install operators, at least the ones I've talked to, in a namespaces so they can control that scope. until they understand it.
Yeah, and again, I think that goes down to another UX problem. I don't think that's necessarily
Yes.
a
I
technical
think that is a UX problem that's probably solvable, that we divide the operator visibility from actual operator scope, so that we can separately control in which namespaces an operator is visible to potential users and in which namespace it isn't, right? That's certainly something that you can separate out, and that would come down to an admin installing an operator and then providing a list of tenants who are able to use that operator, and that would steer the RBAC creation and the visibility and protection of the CSVs, which is really coarse-grained today, right? It's in all namespaces that the operators watch this. So I think that is definitely something we can look into, and we plan to look into, to separate from the actual decision, what can the operator reach in terms of namespaces in general. So I'm interested to hear your thoughts around the scenario where you have lifecycle handling of the API decoupled from the actual controller, and what you think the UX would look like if I have an operator installed in the namespace mode, and then 2 weeks later, because of another operator getting installed, that same operator is again attempted to be installed, but this time in all namespace mode.
Yeah.
How
So
would you propose the system to react?
That's one of the use cases that I think adds to the trickiness of the UX problem that I see with the dependencies. I think what we need to do to solve those problems is to write them all down, right? So one of them, like you mentioned, is that one. Then we've got things the other way around, where if you've got something cluster scoped and then you want to override it in a namespace, you've got that problem, all kinds of things like that. For the one that you mentioned, I think that if I was a customer trying to do that, the message that I would see at the moment is something along the lines of, I can't remember what the message is, but I can't do this because that would mean that this operator group over here overlaps and stuff like that. What we could do with the UX there to make it easier is to say, I can't do this because you have another operator managing this that would overlap because it's a namespace scoped and this one's cluster scoped. Would you like to extend the namespaces of that operator to include this namespace, or convert that operator to a global, to a cluster scoped operator, right? And give them and lead them into ways to solve the problems. And I think if we can enumerate the problems and then kind of think about how do we detect them and lead the user into solving them, then if someone comes along with that problem, then they can go to their cluster admin and say, hey, OpenShift's telling me I can't do this because this would need to be cluster scoped, and then the cluster admin can get involved and say, all right, okay, so maybe we do need this one cluster scoped rather than just in this person's namespace, and think about it from a holistic perspective.
Yeah.
I don't think there's a good technical solution to be able to just make it work automatically, but yeah.
Yeah,
Right,
I think
see.
we had those. Yeah, so I personally, I think also the rest of the team had thoughts around this, like how this would work and how we could patch an operator group specification or status or whatever to make this work. I guess it always came down to the issue of, if you have 34 operators installed that way in your system, at which point is the admin unable to foresee the consequence of saying, oh, now that operator is going to be global instead of namespace, and that operator gets one additional namespace to watch in order to fulfill this install request. I think that's where the troublesome UX comes from, that you have a permutation of scenarios to predict and to understand in order to make that decision. And I think the average cluster admin doesn't really have that knowledge, right? So that was always the concern, but I mean,
yeah. Well, I
we
think
can
some of that
certainly
can
look
be
at
helped.
that again and see if there's a way where we think that's somehow manageable.
Yeah. But
the other issue
that comes from,
yeah, go ahead.
From the way that they may be installing kind of operators and then changing requirements going down the line, right? If we can encourage them to think about their strategy for operator install up front, right, and say, well, actually, you should be trying to keep operators to specific projects and doing it in this way, and that way you're less likely to have dependency problems across the cluster. I mean, Nick's saying on the chat that you've talked through all these permutations before. Maybe you have, and maybe there are really strong reasons. Well, I know that there are strong reasons that it's a hard problem. I'm yet to be convinced that it's an impossible problem. But if you guys think that it's an impossible problem and can write down why it's impossible, then we have to go elsewhere to work out what to do next, right? But I don't think I've seen that yet.
I think that's definitely something we can work on, and there's a lot of internal discussions, because this has been, I mean, honestly, like a multi-year discussion.
Yeah, I mean, you guys are the experts.
Yeah, but that, I mean, nothing's impossible, right? We could probably do something. I think I want to take a slightly different tack and just look at so some ways that we could maybe address some of these problems, not with scoping, but with different ways to write operators. And I don't have a nice presentation or anything. This is just things we've been thinking about, because, making these decisions would require some transition time. We will need answers for, what do I do if I had a single namespace operator and now that's not an option anymore. Like there's lots and lots of transition things we need to think about. But a few of the things that sound like they actually solve a lot of the problems just with the way you write operators is you can do some of this. Just for some operators, this might work. If you just decide that the CRD is a cluster scope CRD, now you've installed one operator in the cluster, its APIs are cluster scoped. The permissions of that operator can be scoped to just one namespace where that operator does whatever it does. And then anyone who needs access to that API is just granted a cluster rule binding to use that cluster scoped API. And that doesn't solve everyone's problems, but there's some class of operators where this is probably a good model. I think a lot of the existing operators that make up OpenShift, for example, probably fit this model pretty well.
Yeah, and that's the model that we're looking at for our common services, right? That's very similar to what we're trying to.
That's essentially what we're doing, yes.
Yeah.
Right, and that works perfectly fine with this notion of global operators. So let's stepping back from the details of all namespace operator groups, and it puts a copy everywhere. The fundamental thing is there's one instance of this API ownership in the cluster, and that's kind of what we're trying to get to. Another model that might help with making things cluster scoped in that sense is an operator that is installed to watch all namespaces, but by default only has permission to update the status of its own APIs. So you could imagine a deployment controller written this way. By default, it doesn't have permission to create pods, but it does have permission to write a status into the deployment object that says, hey, I don't have permission to create pods in your namespace. So it's a namespace API, I can create it anywhere. The operator, we ensure that it has the ability to update the status. And then an administrator can go in and control what namespaces it's available in just by dropping a role binding to whatever cluster role it needs in any given namespace. And then now everything works just like everything else in Kubernetes, where you just bound a role binding to a service account, and now you can use traditional RBAC tools to manage all that.
Yeah, that's essentially what we've done as well. Yeah, I think those two are the things that we're actually doing right now. So I think that fits very well.
Sorry. So have you got the default right status, Mike, then?
Say that again.
Have you got the default right to your own CR status permission? I didn't think I had seen that in your docs, but maybe you've got that in code.
If the customer, we do have a cluster permission that allows us to project when we know that we need to project into another namespace.
Yeah, but do you have default permission across the whole cluster to write to the status of the CRs that you manage?
Yes.
Yeah.
No, we don't.
Okay.
We don't have that permission, and actually we do by default, but the customer can turn it off, in which case we surface an event that allows them to go and grant the permissions that Evan was just talking about.
Yeah, but I think that was Evan's point about saying if the operator has permission to write to the status, then at least the customer will be in a position where if something doesn't work as they expect, they can look at the status and it'll tell them what's wrong.
Yeah, we could certainly do that. That would be another way of surfacing the event I was just talking about. But yeah, we allow the customers to manually, manage the role-based access control to the namespaces so that we can extend in a way that they see fit for their permissions, or if they trust that we're only going to do this when we're asked for a service using our CRs, then we have cluster permissions that let us extend our role bindings. But I think the important part is we don't watch a bunch of namespaces that frankly we have no business watching because they belong to other products or isolated workloads, and they're managing that as well. So it goes one step beyond what he's suggesting, but that these ideas do fit. Okay.
Yeah, and I suppose the conversation here then is these are very sensible things. Are these things that we want to try and embed some knowledge of in OLM, or are these things that we just want to put out as conventions for people writing operators and maybe get into the operator SDK or something?
I guess I have a question still before we go on about where this would land. So is the suggestion that an operator doesn't come with RBAC by default other than writing status on its own CRs, and it's only capable of watching all namespaces for its own CRs until a namespace admin of a set project would give them more permission? Is that in a nutshell? So that is not, is that not still concerning those customers that there's an operator watching their namespace, even if it's just one particular object type?
I haven't heard from customers, and I'll validate it because I'm talking to another one tomorrow. The watching isn't the issue; it's the permissions to affect the workloads, to be able to make changes in the namespace. And so if it simply watched the operator and wrote out a status saying, I don't have the permissions, as I think Evan was just talking about, I believe that would meet their requirements, but I'd be happy to discuss that with whom I'm talking with tomorrow.
And the fact that the operator they just gave permission to is potentially also having business in other tenants' namespaces. So there's a control path that crosses namespaces. That's also not a concern.
I will check that.
I think
the concerns we've heard are really if the operator can do things that will affect workload in other namespaces, and it actually affect workload. So if they can add pods to a project that might have quotas on, that could affect workload. If they can change labels or annotations or mess with config maps or secrets, then that could affect workload. If they put a validating webhook or something in that accidentally stops people creating pods in different namespaces, and that's going to affect workload in other namespaces. It's when it can affect workload that customers care. If it can just see our own CRs, I think we can get away with that and just explain it and say, no, that's just how Kubernetes APIs work, right?
Yeah, I think you're right, James.
Yeah, and I would like to point out that, even if we go to the, like operators are global approach with OLM and say, hey, you know what, everything OLM is expanding the cluster, right? Like we install an operator and then the API is available and then we create the stuff defined in the CSV right now. OLM doesn't define what RBAC permissions we give your operator. There's no reason why you can't just provide no RBAC defined in the CSV, and then in the description of your operator provide drop this RBAC in each namespace that you want the operator to work in, right? And that would give you the scoping that you're trying to do, and allow OLM to manage the available APIs on the cluster the way we want to do it, right? It's obviously puts the onus on the cluster admin and you guys to educate the cluster admin what RBAC needs to be in each namespace, and it's not as fluid. You don't just press a button and suddenly the operator is available in the cluster. That doesn't happen anymore. But the ability to do this scoping where you're saying the controller is only able to get events and modify resources in the namespaces that the cluster admin wants it to do, you do get that. So it's kind of a choppier user experience, but it allows OLM to continue treating these things as all namespaces, right? And install these things the way we want. But it also allows you to scope things down. The only issue you'd have to watch out for is the dependency resolution when you guys who don't define any of the RBAC in the CSV have a reliance on an operator that includes RBAC, and when we'd install it globally, we install it with all the RBAC defined in the CSV on a global scale. So that'd be something you guys would have to.
I do think we should try to kind of project the end state here that we're trying to look for, rather than how to play with OLM today to get things to work. I think our goal is to not worry about copying stuff around at the OLM level and not worry about scope at the OLM level. And when we talk about a global operator, what I think we're really saying is that there's a singleton, there's a single instance of something that provides that API in the cluster, and it's installed somewhere, and it could spin out separate sub-instances of itself to manage different namespaces. But you know, this allows us to, like, that is an implementation detail of the operator to handle its stuff, and you can still manage RBAC separately across the tenants that you want for that to work in, as you have been today. So I think these two ideas, what you've proposed on the IBM side and what we've been trying to pitch here, are almost one and the same.
Yeah, I can see that now, particularly if the user experience is focused on the management of the RBAC as opposed to the deployment of the operator. I think that gives customers more direct tools to really manage the security in a way that they want to manage it. And so, you know, right now it seems like the user experience is all around where is an operator deployed, as opposed to where does the operator have permissions. And I think that corner, if we turn that corner, I think it gives, at least the customers I talk to, the tools they need to really manage this workload isolation that they're after.
I just want to bring that on some angle that actually started this whole movement to singleton, which is the way we currently do dependencies gets in the way with this problem. So we actually cannot use dependencies out of the box today because there might be an issue where incompatible scope definitions block installation, just as you described earlier, James.
Yep.
So can we picture how dependencies play into this, and the fact that not only do you need to give RBAC on some, you know, basic Kubernetes API in your namespace, you might also need to give RBAC on some third-party APIs, not only in your namespace, but also in other namespaces that you might not even have access to. You know what I mean? So
I think that's the, sorry, go ahead. Well, I think that's the crux of what we've been trying to solve for the past, you know, year. We've been doing a lot of writing on paper, and that's been shared and made available. I think the current trend for us is that you view the configuration of an operator, like the places that it needs the dependencies in, as being static, and you view it as a sort of, since I'm installing things as a singleton, my dependency is satisfied so long as that thing has been installed in the cluster, and we like abstract away all of that lower level into RBAC that can be kind of figured out at runtime, hopefully. Now, and I'm not saying that we should do anything to automatically like make that RBAC happen, as we kind of try to today, because there's multiple ways in which you can use an API and they can be different. And that's where the dependency resolution gets really, really difficult in terms of surfacing the decisions of different configurations of scoping to different operator installations. And even like surfacing that as an option, or as a configuration on a bundle, as in, where do I need this dependency? Which dependency do I need? Where do I need it? How am I going to use it? And then surfacing the different options that can come out of that from a user is particularly tricky UX. So I think a lot of this can live in convention land.
With the convention being that if you require another, if you want an operator and you require another operator, the only way to talk to this other operator is via the namespaces you've been given access to, and you're reconceding your current CR. Is that the convention?
I think that sounds right, unless I'm missing something.
Yeah, I think that sounds right to me too.
So we'd have to make sure that if an operator depends on another operator, that when the depending operator's RBAC is projected into another namespace, that the dependencies RBAC is also projected into that namespace.
Yes.
Yeah.
Well,
So
not even that. There's no guarantee that me depending on an operator means that I need that in the same namespace as the APIs I'm providing to be reconciled, right?
Yeah, that's true.
Like one of the interesting things is,
I was just going to say, it seems like the top level operator here in the dependency chain would at least be responsible for understanding which of its dependencies need to be projected to a new namespace, and then that would trickle down to each of the dependencies in that chain. But you know, I haven't worked through the detailed scenarios, but that seems like a reasonable approach. Sorry, who I interrupted.
So with this,
I think,
oh, go on.
sorry, I guess what I'm hearing here is that the problem of dependencies and RBAC can essentially be delegated either to users or to potentially other operators. Like we can, maybe you have some pattern for dependency RBAC projection. Sounds like IBM already does. That could just be a thing that you use, or you could swap it out with, I don't know, OPA or Gatekeeper or something like that. But I think the important part is to have a good foundation of how stuff works so that you can build different tooling on top. And it sounds like we're heading that direction.
Yeah.
Yes.
So if I would describe this user scenario, a specific example on a cluster right now, with this in mind, it would probably go something like this. I have asked an admin to install an operator for me. And that operator gets installed, registers its CRD, but it doesn't have any RBAC by default. Though it describes what RBAC it needs in some sort of metadata that gets projected into my namespace. And maybe the role binding that contains it, or the role itself that it contains the list of permissions that the operator needs in order to function is already generated, but it's not bound. So that final step is putting the user back in control. Though the operator is installed and has everything it needs to run and is running, it doesn't have the RBAC to do any work in my space. So before I use it, I kind of see a little overlay in my namespace screen and say, there's an operator that attempts to access your namespace. Do you want to allow it, yes or no? And then I click yes, and that would in turn create a role binding and give the operator enough permissions. And that would cover cases where the operator just needs basic permissions on basic Kubernetes APIs or permissions on other operators, and their permissions as well, so that everything is just working.
But there'd either need to be a service account or a person's account, I suppose, with enough permissions to do that projection. So there needs to be something that is able to do that. I don't think we'd be able to get the operators to do it themselves or anything. I don't think that's what we're suggesting. I'm just making sure.
Yeah, I think it would be something that OLM does. So instead of OLM giving all the RBAC by default, it doesn't do that. It creates everything that a user needs to easily approve the RBAC, but that last step is still controlled by the user, very consciously.
So one question we should talk about before the end of the call, at least, is what are we losing with this approach? So what is it that we can do with OLM at the moment that if we decide to apply these restrictions, we won't be able to do anymore? So one is we wouldn't be able to run different versions of the same operator in one cluster. And I think we've all understood that one. And I haven't heard any major objections to it. I know it's something that we have people who would like to be able to do it, but I think it's something that we could potentially get away with not being able to do. Are there any other downsides?
Also not any instances of the same version. So it's really down to a single instance. It's not just one version, it's also not instances of the same version. It's just one single instance. Yeah. Entirely.
I did want to bring up that even those two problems can be solved at the individual operator level. You can write multiple versions of a controller, bundle them together in one operator, have some way to decide how they start up, what namespaces they manage, but that can all be entirely the domain of the individual operator because different operators might have different needs there.
That's
Okay,
a good
yeah.
point. That's a good point.
Okay, so it sounds like no one else can think of any other downsides of restricting it to having to OLM refusing to have more than one controller for an API. So where
No,
would we?
I was going to say, James, this has helped me to realize that it's not, it's the issue that we're seeing is all around controlling access.
Yeah.
And not so much, I mean, some customers are surprised when they realize that there's only, CRDs are global. And that just might be where the customer's at that point in time. But it really comes down to this workload isolation from a security standpoint, which comes back to managing their RBAC. Make it easy to manage the RBAC. Don't make assumptions when they're installed, and let them manage that. I think it solves a lot of problems.
Yeah, no, absolutely.
For instance,
same conclusion.
Doesn't solve this in a service provider scenario when you are providing an OpenShift cluster to a customer and you're using operators for your SRE department, which are shared among the operators that are used by tenants. So an often cited example is Elasticsearch for us, because that's both a popular operator in the user tenant space, but also our cluster logging operator and our service mesh operator depend on that. So in this model, because we cannot run multiple instances, required to bump Elasticsearch, it would get bumped for everyone in the cluster. Yeah. So we still don't get. So I just want to make sure this is voiced here, because that is a concern I heard multiple times from service providers who have that need.
Yeah, I think it's dependencies in general, isn't it? I think we have numerous products which depend on the couch operator, and they may not want to be lockstep in terms of which couch operator is installed. And there are things we can do at the operand level where we can say to couch, hey, your operator has to support and make sure they've got backwards compatibility of these different versions, so that we can use one operator but with multiple kind of consumers all wanting a different version of couch. Do we trust that people who create operators for these kind of dependencies can and will do that?
Well, I think that pattern has to be taught and understood. You know, like a couch operator that can manage multiple versions of couch being deployed, maybe as part of its CR, deploying the appropriate operands. But I think that technique needs to be something that becomes well known, and then perhaps I think more vendors could support that.
Yes, but relying on a technique becoming well known and everybody adopting it is dangerous.
It's a different thing. Yeah, right.
I do see a lot of potential here.
We're talking about fan out here, though, right? I mean, we're suggesting that operators have to support this fan out mode as the primary delivery, so you could have different versions of couch kind of thing versus the one-to-one mapping we see for a lot of products today.
I think I was teasing apart the operator and the operand it deploys. Couch is the operand, right? And so if you're going to have it manage multiple versions, that would be information that would be surfaced in its CRs. And it would be able to, the operator itself would be able to manage multiple versions of its operand that's deployed.
Right. So that,
if you want to call that fan out, then now I understand what fan out is.
Yeah, that's the pattern name that I'm not sure if the OLM guys or the Red Hat guys had put on it in some documentation.
Okay.
Right? So they basically got the single version versus the fan out, which is the more complex, which is they've been steering customers away from because it's complex.
It is.
But now we're suggesting that is a path here, right?
Well, I hadn't thought of it until you brought it up, Joe.
I mean,
Well,
it's.
I don't want to step on it.
Go ahead.
I don't want to step on anybody's toes. There are two separate ways to do the same thing. Even with the single operator version, you really want to support more than one depending on what you're upgrading from, because like anecdotally, if you're going to manage, let's say, updating your operands from one version to the next, and your operator version is tied to your operand version, if you upgrade your operator, that means that you're updating all of the operands, right? Because this only manages that version, which means it does have to understand something about the n-1 or n-k versions that it cares about upgrading from, of both the operator and operand. You're just, tying the upgrades together. It's probably more powerful to have an operator that can handle multiple versions or a range of versions.
Yeah, and that's definitely what we're doing at IBM, right? So that is the way that we've been going, but making a change to making a restriction in OLM that means that people have to do that and dependencies might break without it is where I see it being dangerous, but potentially the benefit of doing it outweighs the danger.
I also see a huge potential for the operator SDK to help with the management of operand versions here.
Mm-hmm.
I think what's been happening, and I think this is why we've seen an explosion of complexity in OLM channels, is that everyone has been pushing their operand update graph and support statements into channels and update graphs for the operator itself. So I think what happens is if we build really good tools to make operand updates work properly, make it easy to manage that graph in an operator, then channels and updates probably become very simple from a user perspective, and there's a lot less decision making to do. It's probably like just stable and fast, or maybe like just stable v1 and stable v2 or something like that.
Yeah, and that is an approach that I have been kind of proposing internally on our product, where we've got kind of 6 different large teams making operators for their products, and we're trying to convince them all to do things in one way. When I proposed that, people were worried that customers will not like any change of any code unless they kind of wish for it. So yeah, that got pushed back from a customer standpoint. I haven't explained it well, but from the EUS perspective is really where it hit home, where if we just had a stable channel for our operator, and that's what I was suggesting. I said, well, let's just have a stable channel for operator that can reconcile an EUS version of the operand, but also let's just keep updating that operator as we go forward so that it can also reconcile the next continuous delivery version and everything else. And the customer will just have to rely on us not making a mistake and affecting how their EUS operands are deployed under the covers. And that was rejected as we don't want to do that because that would involve having code updates for customers who think they're on an EUS stream and should only be getting fixes, but really they're getting some new feature through the operator.
Yeah, I also wouldn't underestimate the complexity of moving between versions. And I don't think there's a silver bullet with any kind of SDK or something, because in the end, it's all application specific. It's not going to be the same across operators. And there's also no enforcement today that you can only update from one operand version to another. So this feature that OLM gives you with the graph, which is enforced through OLM, isn't available for operands. And that is creating, a support matrix that every operator would need to support, which grows exponentially with each release. Because
but I can see that there are features we could put into the operator SDK, like hook points for when an upgrade needs to happen, so that the operator code can just say, okay, well, I've been told I need to upgrade from this version to this version. Can I do it? And that kind of thing. But you're right, we're not there yet. And getting operator developers to get there and understand it and actually start releasing operators for it. It's going to take time.
This would certainly help with the UX, that you are wondering why you cannot just put free 5 there when you had free 3 before. But in the end, the migration work doesn't disappear and is not automated in any way, right?
Yeah.
So, and it will pile up. So I think the pattern where we have channels that denote a certain compatibility of release coverage of an operator versus to a range of operands will likely not go away. This is just something that contains the things you need to manage at once in the code base that you have. And we have multiple products in Red Hat that already struggle with this.
Yeah, it's a hard problem. And again, it's something that I would be worried about putting in the hands of every operator developer and saying, if every operator developer does it right, then we're all good. But if they don't, then things break.
Well, the blast radius is limited to a specific operator and set of operands. So
yeah,
I don't know how concerned we necessarily need to be about that. I think right now, like, you can't even tell what set of operand versions are supported by an operator. Ideally, like what I'm envisioning is, like, if you put 3.5 in the spec and there's not, and you have 3.3 installed, then you either get a message saying I'm working on upgrading, or you get a message saying I don't know how to upgrade from 3.5, 3.3 to 3.5
And
that just seems like with operators.
We've built something that does just that for our products, so that in the status of CRs, it advertises which versions are available to upgrade or downgrade to, so that customers know which ones they can switch from and to, and then we put that into a UI. So we have approached those problems and we know how to solve them. It wasn't easy to do, but
again, this doesn't solve the core problem that that the upgrade of the operator is going to have cluster-wide impacts, and that will impact cluster-wide the ability to run certain workloads. So with the single operator pattern, we need to be really sure that we message this correctly, that if it's employed, that means the range of operand versions that your operator can reconcile is going to be the same for any tenant. And the extreme ends of these ranges is going to be what the operator needs to support. And that will make your tenants either happy or unhappy.
But if we can start putting convention around how the supported versions are advertised, then at least OLM can do things like say, well, we've still got operands at this version, and this new operator doesn't support them, and therefore we're not going to upgrade it until that problem is resolved, right? So there are UX improvements there as well, that could be very useful.
Sure. Yeah, that would give a lot of visibility into why you cannot just, or what would it mean to update. You would cut off certain operand versions. So I think that makes a lot of sense.
Yeah, and a lot of people kind of try and tie that to API versions, and really it's not, right? It is definitely operand versions. You have multiple operand versions at one API version.
Okay, what are the next steps? And do we want to work on a draft that describes the transition of RBAC control to the user in this world?
I think we've come to I think we've kind of come full circle here, and the conversation meets where we have been internally, I think. And the next step there was writing a proposal on scoping, or more specifically unscoping, and which would include like migration. And I think Evan started working on some of the migration stuff. Maybe he has a better handle on what to say.
Yeah, I've definitely started working on a proposal for how we could potentially get here. I think this was a good testing ground for some of those thoughts. So I think this was really helpful from that perspective. Happy to make, I don't have anything beyond a smattering of notes that I hope to organize at some point. So I don't know that it's ready to collaborate with, but as soon as it is in a state that is ready for review and collaboration, I'll be happy to share it out.
Yeah. So I think we've got a few different spaces to write up, don't we? We've got the how do we migrate from where we are today to this model. We've got how would we want operators to advertise available versions and available migration paths if we want to start kind of prescribing or at least having a convention around how that's done. We've got how and what would project RBAC positions and when and how we would understand which ones we need for which dependencies. What else? Does that cover the whole solution.
I think that was a pretty good summary.
What about your RFE, James, that you put in the notes and into OLM issues?
So it's one that I would have loved to discuss at this meeting if we had time, but we're running out of time. And actually, I think the meat of it will change depending on if this is the path we go down. In short, it was really, at the moment, we kind of really tie operators to their controllers to their APIs, which means that if you want to try and install two different controllers, OLM has no chance of working out which of the CRDs is the right one to install and which webhook and stuff like that. So I was saying we should break out the API into an API package, which doesn't have any cluster permissions. It's allowed to run a conversion webhook and install a CRD, and that's all it does. And then a controller package would depend upon that, which means that you could have controller packages at different levels and therefore have different versions of the operator installed in different namespaces without having that CRD conflict, to try and ease some of the sharp edges around that. But this discussion kind of changes some of the basis of whether we would need that, right? If we've only got one controller for each API version, then you no longer need to worry about that in the same way, except maybe for the ingress style operator, where you might actually want two controllers who are doing different things but to the same API. So it might still be worth thinking about, but it's not as important as this discussion.
At the same token, that last one, could you not just have a controller that spawns two other controllers? Right?
You could, but that would require those controllers to be packaged together somehow. Whereas with the ingress model, you don't necessarily have the same organizations working on each controller. Yeah, you could probably do something with a proxy controller or something at that level. But yeah,
that's fair. That's fair. I think the new ingress model actually does use different APIs and duck typing, but the old one, that is a good point.
Yeah, that's kind of a side issue to all of this, I think. I mean, that's a solvable problem that we can come up with resolutions for if we decide it's big enough to need solving.
I think it's also possible that the model you outlined with an API package and controller packages is something you could just do. You could just have your quote unquote operator be the API package, and then the only thing left would be the ability for OLM to install packages that don't own APIs. And then you pretty much, I think you get that model for free if you want it.
Yes, but then you do lose some of the ability that we have at the moment, where if a controller package owns an API, that it does the operator group scoping and all of that kind of stuff. But again, those problems are going to go away if we go down this model of one controller per API. If we were going to do that and still maintain the ability to run multiple controllers, then I think you could just about get away with putting the packages in separately with today's infrastructure, but it would be better to harden it with OLM support for specific package types.
Okay, well, it sounds like we should discuss that more at the next one then, because I think that's interesting in the context of what we've been talking about here.
Well, I'd like to see what you write down based on the discussions we've had today, and then probably, have a look at the APIs and controller decoupling together and say, well, is it still worth it? Would it still provide benefit? If we're going to rewrite a lot of stuff to make this model work, then maybe rewriting it in that way for flexibility in the future is the right thing to do anyway. Who knows? We can think about that when we get there. That's a technical implementation discussion, isn't it?
Not sure it's clear to me what the best thing is right now.
Yeah, exactly.
Yeah, maybe we should, sorry, I didn't mean to interrupt you. Go ahead.
No, I finished.
Oh yeah, maybe it seems like, so this conversation does require a lot of, especially about the kind of descoping, I should call it, and dependency resolution, and the kind of tree of things that branches off of that. It requires a lot of bootstrapping every time we start the conversation. People come in fresh, different levels of having understood the problem, and it is a difficult problem to explain with use cases. And at the end of every one of these meetings, we seem to go into a phase where we say, well, okay, we'll write more docs on it. We have a good amount of docs, I think, right now. I think the next doc should be this kind of formal enhancement proposal of like the end state plus the migration, so that we can kind of say, let's put these conversations on hold until we have that, and then we can actually like do a real review on it.
Yeah, I agree. The other complexity that I can foresee is the conversations around where we run these operators. At the moment, we run cluster scoped operators all in one namespace, but depending on some security stuff, we might not want to continue doing that if they've all got access to config maps and secrets and things in that namespace. Again, it's an implementation thing. I just thought I'd throw it out there because if Evan's going to write some proposals, then he might want to think about that as well.
Yeah, that's definitely one of the topics that needs more fleshing out. There's a bunch of options.
Yeah, cool. Cool. I don't think I've got anything else.
All right, well, I think this was a really productive call, so I'm glad we had as many people in here to discuss the future of OLM basically with a much broader audience than we may do all the time. So this was wonderful. Thanks for being here, and I will see you all next week at the OLM Dev Working Group meeting.
Cool. Thank you,
Thanks,
Alex.
guys.